Okay, today we are doing 10-1 operations on matrices. Again, we are skipping the trig portion. We need to get matrices in there. We need to get a few probability statistics stuff in there. So we got 5 weeks left, so we're going to matrices. So matrices, you actually have seen them. Anytime you get a table that you're supposed to read, get information off of, that's a matrix. Anytime you go to your playlist on Spotify or Apple Music and you see it listed out, a spreadsheet, it's a matrix. Okay? So a matrix is just a way to order things. It's actually used in encoding and decoding messages. So if a government is encoding messages to send them somewhere else, you have to know the equation that undoes that in a matrix. So they're kind of fun to do. If we have time, we'll do some of that encoding, like encoding and decoding, to just have a little fun with it. There's a lot of words on here, so be careful. Don't write all of them. A capital letter can name a matrix. This is matrix A.
A. Got it right.
Okay, so that's matrix A. There's other ways you can name a matrix. You can name a matrix by its size. And the size, we can also say size, order, or dimension. And that's not something that's going to be pushed here, but those are 3 words, size, order, dimension, all the same thing, is rows by columns. Okay, so it's rows by columns. So people sometimes get mixed up rows and columns. Well, first of all, columns are up and down, yes? Rows are side to side. So we usually don't get that, but which one comes first? Now think about it. If I'm going to build a column, I start with individual rows stacked on top of each other, right? So rows build columns, so rows have to come first. Okay? So this matrix, how many rows do I have?
3.
3. And how many columns do I have?
2.
2. So it is a 3 by 2. Now I could also write this in a 2 by 3 if I just lay it on its side. So 7, 5, -2, 0, 4, 8. Sometimes you can just write them in that way and sometimes you can't. You can't change something that was given to you to make something work. But if you were writing your own from scratch, you could do it either in a 3 by 2 or a 2 by 3. Kind of similar to what we do when I showed you guys how to multiply polynomials that we had more to do, right? We made a matrix. We just had a grid. Okay, it was a matrix still. You've seen matrices like this one over here on the right, where it has the rows labeled with something and the columns labeled with something, right? When we go to just matrix form that's over here on the left, we tend to, in the description, tell you what those things mean, and then we don't write them anymore. Just cleans it up a little bit. So an element, a specific element is a thing. 7 is an element. And its position is A. Well, actually, we'll go to 8. Okay, we're going to 8 because I have it here. So it's lowercase a because the matrix name is what? A. So lowercase means element. And 3, 2 means the third row, second column. So A sub 3, 2 is 8. So what is A sub 2, 1? Second row, first column is -2. Okay, so over here, that's why they have A sub GJ, because it's the J row, G row, J column. Okay, so this element right here is A sub HK because it's the H row and the kth column. You say kth.
No.
The kth column. So you have H row, kth column. Make sense?
Yeah.
Questions?
8.
8. The H. Okay. Any questions about this? A lot of words, but not like a lot of symbols that can make up those words. Matrix they clean things up. We used a matrix when we did row echelon form, did we not?
Yeah.
When we used reduced row echelon form, we made matrices. We didn't do anything else with them other than make them, and then we used them to organize our work. That's what their purpose is. Okay. We can add them, we can subtract them, we can multiply them. What did I not name? Divide. You cannot divide matrices. It does not work. We can multiply by their additive inverse, the multiplicative inverse, all those kind of things, but we cannot divide matrices. There is no math that does that for me. There's no operation.
I thought you couldn't multiply, you couldn't divide.
You're just talking basic integers. So integer math is different than when we actually have an object. A matrix is an object, and there's no math procedure that allows you to divide them. So we do things like multiplying. We find the inverse of things, and then we can multiply by that because that's the way to move one from one side of the equation to the other. But we can't divide them. Okay, so we have Cool Threads as a clothing store. It uses matrix C to represent the price of women's clothing. Columns represent brands: vintage, casual, distressed. So in your brain, you see this V, C, D. Rows represent jeans or jackets. So we have jeans and jackets. Okay, again, this is something. Do you guys want me to shut off the lights?
Yeah.
Is that better?
Yeah.
Okay, so in my brain, they typically don't write that. Okay, so in my brain, I know vintage, casual, distressed, jeans, and jackets. Okay, so how much is a casual jacket?
210.
110.
110.
Oopsie daisy.
A casual jacket. That's in position. What position? C sub what?
See, so
2, 2. It's 110.
2.
Okay, so that's gonna. Somebody can read that. You've read things like that before, right?
No.
You have never read a table.
No.
Not by 2. So.
No, you've read a table. If I said jackets, casual jackets,
Oh,
you've
yeah.
read a table like that. Yes.
No.
Yes.
and wait.
If I wanted to know how much vintage were, I would add them up. Yes.
Yeah.
And I could add this, and then I could get add a total here and a total here, and then I could get a grand total. You've seen tables like that, right?
Yes.
Their base is a matrix. We just don't put that other stuff out there because at this point you know you can add those rows up and you know you can add those columns up and get that end result. So it's unnecessary to put that in front of you, isn't it?
Yes.
So it wants to know what operation I could do to this if I want to have a 5% sales tax and I want to know the amount of the sales tax. So what would I have to do with each of those things times each of those things by 0.05, wouldn't I?
Yes.
Yeah. So how I show that is I write C parenthesis, guess what? 0.05. So that means I'm going to take 0.05 times what?
All the rows.
Every single one of the things in there.
So can't we put that into the calculator?
Well, I'm not going to show you how because you're going to do my hand.
Yeah.
No.
Okay, so it's 6 things. You can do it. These, you see how this, I wrote C, what's C?
C is
Matrix.
Matrix C. Parentheses means times, right?
Yeah.
What?
0.05.
0.05. What does this mean to do? The same thing, doesn't it? These are different ways to write the same thing. So, I have 5 times 32. So that's 2, carry a 1, 160. So 16. Is that right?
Yeah, it is, because 15 and then 1.
I took 2 times 5 is 10, carry a 1 is 15 is plus 1 is 16, right?
Yeah.
And then I add a 0,
160.
and then I move it over twice, so I get 16. you need a calculator, I guess you need a calculator. But you can do this math, yes?
Yeah.
Okay, 5 times 21, so that'd be 105. So that would be 1050. Because you have to add a 0 and move the decimal twice. Again, if I need to use my calculator, am I using my calculator?
Yes.
Is anybody checking me that I'm doing these right?
Nope, because we believe in you.
You trust me? Okay, so 5 times 16. So we have a 0 at the end already, right? Then it's 30, so I have another 0. And Kara 3, 5 times 1 is 5 plus 3 is 8. So move the decimal 2 places because the 0.05 and I just get 8.
Good job.
Hey, I did that.
Okay, so 0.05 times 240, so I already have a 0, right? 4 times 5 is 20, so I have another 0. 5 times 2 is 10 plus 2 is 12. Move it twice, so I just get 12. Okay, 5 times this, so it'd be 550. Yes? Move the decimal twice is 550. Now I have to put the 50 there because it's money, right? So I probably should put 550 there. Okay, now this one's gonna be a little longer. So 5, right? And then carry your 2, so it'd be 3, 2, so 350.
Yeah.
No,
325, yes. I had a 2 there and I didn't say it, did I?
No.
You said 2 something.
I said 2
you were like,
and then
5.
I 50. Okay, so how much tax do I charge on each of those things? Can I read that?
much. Those numbers.
Okay, so vintage jeans, how much tax gets charged?
$16 extra dollars.
$16 extra dollars.
Oh,
For distressed jacket, how much tax?
Rest, yeah,
$3.25.
$3.20.
So are these things useful?
Yeah.
Yes. In most inventory systems and POS systems for businesses, matrices are what they're all built around. Because it plugs it into it, it multiplies by its position. Programming has lots of matrices. Questions? Okay, so what this thing is called right here, it is called a scalar. Scalar multiplication is multiplication of each element of the matrix by a single real number. Is that what we did?
Yeah.
Yes. We just did scalar multiplication and they didn't even have to tell me how to do it.
Yeah.
Because it made sense. It was doing the math you would have already done. If I told you 6 things and I asked you for the tax on each of them, wouldn't you have just done that?
Oh, wait,
Yes, it would have not been organized like that, but would you have done the same thing?
Yes.
Yes. Okay, so scalar multiplication is the process of multiplying everything in there by one thing. I had written it like this, yes?
Yes.
And I had also written it like 0.05 times the whole matrix.
Yeah.
Sometimes, and I'll do it a lot, I can write it like that, can't I?
Yeah.
It means the same thing as the very first one. Usually when it's a decimal, I write it like the first one. And if it's a whole number, I write it like the last one. It's just what my brain likes to see, what it acknowledges better. With the last one, I tend to drop the 0.0. With the first one, I do not. Can anybody tell me why my brain would maybe drop the 0.0 with this one and not with this one?
Because it's an even number.
No, it is not. Look at it. Look how I wrote it.
Your matrices at the end.
My matrix is it, but I also put parentheses around the first one, didn't I?
Yeah.
And anything there's in a parentheses, is that all important? Yeah. And sometimes when things are not in parentheses, we tend to drop them off because I multiplied by 5 every time. But I had to remember to move my decimal how many times? Twice. And so I have found in my brain that I need to write it like this to make sure I do it all. Does it matter how I write it? No. And the reason I tell you guys those things is not that I want you to do it my way, it's I want you to find a way that you don't mess it up. Okay? Yeah, I'm not going to show you how to use your calculator till the very end. You need to know how to do this basic stuff by hand. These will be on the ACT. They're quick, they're easy, they are very quick problems to do. They will be there. The first 20 questions in the ACT, you should have them done in less than 5 minutes to get through the whole thing. So, why? Because the later ones take longer and you have 60 problems with 60 minutes.
I can get done
So, yeah, I'm sure. Okay, so it would take you longer than that to just bubble random. Okay, do we need to do another example of multiplying by 6%?
No. Yes.
Yes.
Okay, so I need 0.06 of C, right?
Yeah.
So I'm going to multiply everything in here by 0.06. Okay, so it's 6, not 5 this time, so you might have to check my math a little bit better. Okay, so 5 is 30, 3 is 45, so it's 450.
Yeah.
Okay, 6 is 24, so it's 240. 6 quarters is $1.50, so 10. Nope,
Why are you
$1.50.
faster than the calculator?
Because I'm just reasoning through it. 6, so 6,
Oh, never mind.
360, and 180. Okay.
I did that math time, so.
You all know 3 times 6. You all know 6 times 6. You all know 1 times 6. All I'm just doing is adding zeros and moving decimals, yes? If you can do that basic math, I did it quicker than you did it in the calculator punching that all in. And I didn't do any math that you guys haven't known since 3rd grade.
Well, we're not quick.
Well, but you don't get
She
quick
knows.
if you constantly use a calculator, do you?
I'm slow brain.
I'm a quick, fast man.
I'm going to tell you, your guys' math skills have improved substantially from the beginning of the year.
There's no way.
Just to let you know. They
My
have.
factoring skills have tremendously, but nothing else.
Oh, I think you would be surprised. Okay,
Yeah.
What about me?
Tremendous.
any questions?
No.
Okay.
They just want to be.
So now I've got another situation. Cool Threads also uses matrices. And guys, they're giving you these examples because they are real world. They are used. They're not this basic, but they are used in those POS, point of service. That's what's called point of service systems. At Maurice's, at Walmart, at Arby's. They're using these in their programs. Okay, so Cool Threads uses matrices to keep track of their monthly sales. Okay, last hour I sat down and didn't teach. You want me to do it again?
No.
Then I expect you all to be paying attention. Okay, so matrices A and B, row 1 represents jeans, row 2 represents jackets. Then we have vintage, casual, distressed again, just the same order. We got to keep those same orders if they're going to represent things. Okay, this time it's not the cost. This time is the number of things I sell. So in March, how many distressed jackets did I sell?
40. Wait, this rest is the 3rd. 28. 35.
35. Distressed
Oh,
jackets. Okay, distressed and jackets is second row. I sold 35.
Yeah.
Okay. In April, how many distressed
45.
jackets? 45. So this is just how they're keeping track of it. How would we use this, or what would we do if you wanted the total sales for the 2 months?
You would add them together.
Like every single,
Like you would add
Yeah,
the
like
bottom
row
row
one,
with the
and
bottom
so you would do
row. Top row with the bottom.
matrix A plus matrix B. You would simply add the vintage jeans to the what? Vintage jeans. So do it. And you would add the casual jeans to the what? Casual jeans. Same positions, add them. So did you get 32, 28, 53, 26, 24, 80?
Yes.
You added element to element.
Mm-hmm.
You just did matrix addition without me having to tell you how to do it.
Let's go.
I did.
Does this work if I don't have the same size matrices?
Yeah.
No,
Probably not very
no,
well.
it does not work at all because you have to add the same thing it's combining like terms, guys. Would it work if one of those was a 2x3 and the other one was a 3x2? No, because it's 1 1 to 1 1, 2 2 to 2 2. Okay, it's the position added to each other. Make sense? So we need to note to add, they have to be the same size, right? What do you think about subtraction? It has to be the
They
same
have to
too.
be the same size.
Oh. Anybody know another word for the size? I gave you 3 of them. Size, order, and dimension. Dimension's kind of easy because we do a 3x2. Isn't that how we do a dimension of a room also?
No. Yes.
Yeah.
That's not how I do
That's
it.
not, that by is multiplication because that's how you get area. But we say by. We don't use it for multiplication. Okay, so this one says, what is the difference in the numbers of the terms, items sold each month? So what am I going to do now?
Well, the bottom one, like the jackets, is 130. Because I accidentally did that instead of counting.
No, they want of each thing. What is the difference in the numbers of items sold each month? What would I do? Subtract them. And if I want to go from change from month to month, I don't subtract April from March. I subtract what? March from April, right? You take the second minus the first. So we're going to do B minus A. And this goes for both.
Wait.
So I'm going to take 18 minus 14 and what?
You say we're taking March minus April.
No, I'm taking March from April. I never said March minus April. I said March from April.
You gotta use simpler words.
Okay.
What?
An application problem is going to say March from April, isn't it? It's not going to say April minus March. It's going to say March from April.
From April.
You subtract March from April. Is that what I did?
From April.
I'm subtracting March from April.
Yes.
Okay. So 16 minus 10 is 6. 17 minus 11. 6.
Negative 6.
Negative.
9 3.
9 3.
Negative 3.
Negative 3.
11. 10.
Austin, good math.
Thank you.
Okay.
Wait, you put 11.
You put, yeah, you did.
Already said.
Got him.
Okay. So that means, did all the sales go up?
No.
No. What went down?
Your
the
distress jeans.
Distressed jeans.
your
And I-
casual jacket.
And I'm going to tell you right now, I always try to say my row first because we do everything row column. And I understand why you did distress, whatever. I get it. But if we do everything rows columns, would it be a good thing to do to train your brain to identify things rows columns? Okay, so jeans and what brand? Distress and jackets, casual. I know it doesn't sound right at all. But
Casual jacket.
we do things row column, and it just helps train your brain.
Yeah.
Just take away all the English.
We're not most
No longer
languages
going
mix
to
their
Screw it.
things around anyway. Okay, so we learned that we can add them and subtract them, but what has to be true?
They have to have the same dimension.
They have to say the same size, order, or dimension. And I can't flip one on its side. It doesn't work that way. They have to be exactly the same.
Yeah.
And do I add all of them up?
No.
No, I add corresponding
Yeah.
elements, correct?
Yeah.
Okay. Well, this one just says to do m plus n and n plus m.
Yes.
So do it.
No. And minus.
Yes.
No,
Where's it
m
say?
plus
I was
n
looking
and
at the
n
Where's it say?
plus
I
n.
was looking at the bottom. Go down.
Okay.
At the top.
Well, we know. That's the same thing.
Is that called Isaiah? Yeah.
But Isaiah is saying that made me think maybe I typed one of them wrong.
You did.
I'm checking, but I don't think I did.
You did.
It's probably just, oh look, they're the same.
They do buddy.
You guys got them written down yet? Or you just put your answer down?
Whoa, what the heck?
No, I didn't put the other part of it on there.
No, I think you did.
Okay, so we're doing this, and then we're gonna do this and this.
So are we still doing plus at all?
You're doing plus, and we're gonna do minus.
Go.
We're gonna do all four. You done adding?
I am now.
Okay,
How'd you get two?
Because you did.
I
Point two.
got point two,
Look at the
zero
decimal.
plus point two.
Look harder.
Well, if there's a zero in front of it, assume there's a dot.
Yes.
Okay, so did I get the same thing?
Yes.
Yes. Is addition, that's called commutative, right?
Yes.
Okay. Is addition commutative in normal numbers?
No. Yeah.
Yes.
No.
Yes. Matrix addition is commutative. Not all the rules apply. Okay. So in integers is subtraction commutative?
No.
No. So what do you think is going to happen here? Do you think it's
They're
going
gonna
to?
be flipped.
Okay. So well, let's do it.
So 6 minus -3.
No.
Like
Oh,
you do it,
negative.
and I'll do it. So then Austin can't yell out random answers.
Hey,
If you're doing
Austin
n
knows all
minus,
the answers.
yeah, you silly goose.
if you're doing n minus n, then it would be 6 minus m.
Just do it on your
Just do
paper.
it.
6.
Hey, what's -3 mean? Like,
Wait, that's not six.
it is not.
It's not six.
I was like, did I forget how to math?
No, I just
She forgot how to math.
I did.
Struggling today on the math department here.
Oh, that's not even that.
Yeah, I was gonna say.
I give up today. 2 cups of coffee and 3 Diet Dr. Peppers does not help your brain focus.
Yes, it does. Are you sure?
Are you sure?
Not unless you have ADHD.
At least it was diet.
Nine.
Austin, I am recording.
I don't know what you're calling.
Okay, do you think it always happens that way?
Yes.
No.
Yes, it does.
Okay, are they equal?
Yes.
No, they're.
Yes.
Are they equal? No.
No, they are not equal. They are the negativeness of each other.
The zero is
Yes.
every-
Okay, not reciprocal, just negative. They are the negative of each other, That does not always happen. They just put their numbers in there. Why did it happen? Because the specific numbers they chose.
Yes.
Okay. But you see, it is not commutative, is it?
No.
Okay. That is the only two things that hold true. Multiplication in integers is commutative, yes?
Yeah.
On Wednesday, you will see that multiplication of matrices is not commutative.
Alright.
So when we add, we're good. When we subtract, are we good?
Yes.
No,
they're not
I mean,
saying
no.
No, we are
no.
not. And again, we can only add and subtract matrices with if they are the same size, order, dimension. We cannot do it any other way. Now, I don't know if we need to continue to do examples of this, but I want to know which matrices that I can combine through addition or subtraction. Can I do A plus B?
No.
No.
Because they're not the same
Not the
dimension.
same dimension.
What's my size here?
Two by
12
three.
2 by 3. What is here?
2 by 3.
3.
What is here?
3
by
by
3
2.
by 2.
2 by 3.
2 by.
You can't do anything.
Okay.
with these.
So, does it help to write those out immediately?
Yes, it does.
Yeah. So I could add, subtract A, D, and C, yes?
Yeah.
Okay, could I subtract A and D and then add C to my answer?
No.
Yes.
Yeah.
Go crazy.
I can put A, and I could write it just as A plus D minus C. That's all they have to put on there. These tests are nice because I just put a bunch of matrices at the top, and then I just write A minus B, or 2 times C.
She's giving us the answers to
Okay.
the test.
Yeah. So, can I do anything with that 3 by 2?
No.
No.
No. Okay, which 2 matrices will give you a 0 matrix? Oh, wait a second.
B.
What is a 0 matrix?
Oh, 0.
When all
The whole thing's
zeros.
All zeros. Okay, the 0 matrix is also called the additive inverse. Why?
Because
it
when you-
also
Because
does that.
they're inverses of each other. I don't know.
When you
They're
add them.
opposites.
Okay, when we solve an equation, we do the inverse operations, yes?
Yeah.
Yes? And when I add or subtract things to the other side, I'm trying to get a 0 on the side it started with, correct?
Yes.
That's we're using the additive inverse property. Okay? So the additive inverse gives me the 0 matrix. So which 2 of those would give me zeros if I added them?
A and D.
A and D. Because if I did A plus D, I would have negative, or yeah, you know what I'm
Negative
saying.
0, negative 0, negative 0.
I would have 0, 0, 0. Now, would that work if I did A minus D?
You forgot your
No.
negatives.
No, that wouldn't work. It's called an additive inverse for a reason. Okay.
What's the reason?
And how does A plus C and C plus A relate? Are they going to be the same answer?
Yes.
They're going to be equal. And we
Yes.
saw that in the last one. We didn't even need to do it. So I wanted to talk about additive inverse. Do you know what the multiplicative inverse is?
No. It's
Or when
their
you
fractions
multiply
of
them.
the whole
When I multiply or divide by something, when I'm solving an equation, what do I get? I get 1. So we have the multiplicative inverse for these. We want to get 1s. I shouldn't have said that. Never mind. I went somewhere I didn't need to go. Okay, so additive inverse gives you all what? Zeros. And I think that is it. Nope, wrong one. Oh, what is the additive inverse of B?
Negative 6. Negative 5. Oh, we're going down.
I like to go down because then I stay in a row. These should be all rowed and columned up.
Negative 6 to negative 3.
2, negative 3.
Negative 5. 0. Negative 0. 4.
And 4.
Okay.
You write your negative on the 0.
Helpful comments only.
With them.
And that's it.
You messed it up.
Yeah.
Okay. So you should have plenty of time, but I'm going to tell you right now, do not just run me answers. Label what you're doing. If it wants A sub 2, 3, write A sub 2, 3 equals.
Hey, Fred, are you gonna grab me a book too?